Okay, good morning. So we are going to wrap up this last portion of lecture 7, I believe. Yeah, which is the hearing. Now we already labeled the ear last time, and so we're just going to go through the slides corresponding to the diagrams. I already told you that there are two sensory functions for the ear for detecting the sound. And now we know, after labeling the diagram, we know that the detection for sound is uh, uh, it's going to be the function of the cochlea. And, it's going to take the information to the temporal lobe. We wrote temporal lobe last time here. As for the detection of equilibrium, the information is going to go to the cerebellum, but to detect the equilibrium, we rely on the vestibule and the semicircular canals. Okay, so you might remember the cochlea looks like the snail shell, and we have the vestibule kind of in the middle, and then you have your semicircular canals. Okay, so cochlea, vestibule, and then your semicircular canal. Okay. Now the receptor that are responsible for detecting these things are all examples of hair cells, which are a type of mechanoreceptors that help detect changes in pressure or body movement. And they're located within these various structures. Excuse me, they are located within these various structures, and they respond to various movements of the head as well as of the body. Now we already label this, but the ear is separated into outer ear, middle ear, as well as inner ear. Okay. Outer ear includes the pinna, which is the ear, and then the auditory canal. We also have the tympanic membrane, or the eardrums, right? And then for the middle ear, we have the three ossicles, like stapes, incus, malleus. Together, they're called ossicles. They are responsible for amplifying the sound that's coming in. And you can see the stape is going to be pressing on the oval window. And last time I briefly told you that the oval window is going to send the shock wave inside the cochlea, and then it's going to come back, and the excess pressure is going to be relieved from the round window. So as we pushed in the oval window, the round window is going to pop out. Okay, and then when the oval window retrieve, the round window will go back in. And so there is this, out of sync action that help balances the pressure inside the cochlea. We also have the auditory tube here, right, or Eustachian tube, right, for equalizing the pressure with the environment, or with the surrounding. So let's just go through some of these in writing. Pinna, it's the visible part of the ear. Right? It's made of cartilage, right? Made of cartilage. So that's why it's flexible. Like you can fold your ear and then it's gonna spring back to the original shape. The auditory canal, also known as the ear canal, that is where the sound's gonna go in, and it has fine hair and some sweat glands, and the sweat gland secretes the earwax. Okay, we talked about the earwax last time, right? Someone asked that question, and it's to prevent the colonization of bacteria. There was an article I read about someone like cleaning their ear with a cotton swab, but then the swab was stuck inside, and he didn't know about it. I guess he pulled the thing out, but then the cotton part gets stuck in there, and he didn't realize it. And over time, it becomes a place for bacteria to start growing. And he actually ended up having a seizure because I told you last class that let me show you the diagram quickly to refresh your memory. I think it's right here. When we labeled the ear last time, you might recall that the inner structures, oh, sorry, I just gotta find the right diagram here. The inner structures are actually protected by the temporal bone, right here, the temporal bone, right? So like imagine if you have the cotton swab stuck here and then there's like, infection. The infection can actually start spreading and then it might end up in your temporal lobe, right? The part of the brain that's really close to the ear, right? And I think that's what happened in this case. And he ended up having a seizure. And then when they do a scan, they actually found the cotton swab that are stuck inside. Okay, the middle ear, we have the tympanic membrane, which separates the outer ear from the inner ear. It's a typo right here, ear, and the middle ear, and converts sound energy into mechanical movement. And then as the tympanic membrane is moving, the three bones are going to be moving in a way that amplifies the sound. So they form a lever system. For those of you who don't know what a lever system is, think about it like this. Like there's a big rock here. Like if you try to lift this, it's very heavy. You can't do it. But if you put a rod and then put like a smaller rock here, when you press down here, you're going to be able to lift the rock, right? The longer the rod is, the easier it is to lift the rock. That's a lever system. Essentially, the ossicles forms a similar type of system, and that's going to help amplify the sound by about 20 times. Excuse me 1 second. So the three ossicles, starting from the most lateral, this is lateral, closest to the outside, right? And then this is medial. We have the malleus or the hammer, incus, anvil, and then stapes or the stirrup. Okay, so the stirrup is attached to the oval window. That's the one that's pressing on the oval window, right? So you can transmit the movement into pressure changes that goes on inside the cochlea. And then we have the hammer, which is attached to the tympanic membrane. So that's like a zoomed in view of the three bones and show how they're connected. And these are the things that corresponds to their other names. Okay, so malleus is hammer, anvil. I'll just write them down. Anvil and the stirrup. Okay, so like this thing is attached to the tympanic membrane. And this here pushes on the oval window. Okay. I think of the three bones, the stapes is the only one that looks like the actual stirrup. Okay. The other two, I mean, you kind of have to use your imagination a little bit. Yeah. Now, some people have a hard time um, visualizing, where this is happening in the face, I'm in the head, right? Like where exactly where are the stuff located? It's hard to see, right? So if you think about the head and you're able to see through, like the inner structure, I suppose that's where everything's gonna be. Okay, so this is your inner ear, and then it goes all the way here, and all these purple stuff right here. That's going to be the snail shell and the semicircular canal and all that stuff. So the ossicle is about here. Okay, so just a little bit underneath the eye, like right here, right? But further in, right, deeper into the head, right? So here, the middle ear, we also, in addition to the ossicles, we also have the eustachian tube, which is, as I say, normally closed, but it will open when you swallow. Okay, normally closed, but open when during swallowing. And as soon as you swallow, it's gonna equalize the pressure inside and outside. Okay. Connects the middle ear to the nasopharynx, equalizes pressure of the head with the outside environment. So it's a little bit more horizontal in kids, but then it becomes a little bit more elevated in adults, which is why, like for kids, if they have a cold or something, sometimes the stuff can drip and then it can lead to ear infection. In adult, because of the slope of the incline, that doesn't really tend to happen. Yeah, like if you had a kid before, like you would know. Okay, like anytime they have some kind of cold or something, it's very easy for it to spread all over the head and into the ear and stuff like that, and then you would need antibiotics if you have an ear infection. Okay, inner ear. We have the cochlea, which is the snail shell. I'll tell you more about the snail shell in a bit. I actually have to draw you a picture to help you understand what's going on. Vestibule in the middle. So remember, the vestibule contains two things that helps you detect vertical acceleration, as in dropping, as well as linear acceleration. More on that later. And we have the semicircular canal for detecting various type of rotation. Yeah. But let's focus on the cochlea first. Yeah. The cochlea, if you open it up, it actually is a big tube, and the tube kind of loops back on itself. And within the tube, there are three separate three separate canal. They all have name: tympanic canal, cochlear duct, and vestibular canal. I'm not going to ask you to memorize all those things, and I'll try to explain to you how that works. Okay, so we probably have to draw this out. Okay. Now, it's hard to explain, I suppose, but I guess I'll use my favorite prop here. This is the toilet paper roll, okay? So imagine the cochlea is all rolled up like that. So what we're gonna do is we're gonna unroll it. Okay, we're gonna unroll the cochlea so that it becomes, unravel into a long tube, right? So if you think about the actual thing, the cochlea, okay, we're gonna unroll it like a tissue paper. But the analogy is not perfect because the tissue paper is wait, something just flashed on the screen. Can you guys still see my screen? Is everything okay? Can you guys see?
Yeah.
Yeah. Oh, okay.
Yes.
Thank you. I don't know, it just went black for a second. Okay, so like the tissue paper is thin, right? Okay, but like you have to imagine the cochlea has some thickness to it, right? So I'm gonna unroll the cochlea, and then it's gonna become like this. It's gonna open up like that, but it tapers off nearing the end. Can you visualize this? Right? So like it's like you can take the end here, and then you keep rolling it, and then you get back to the snail shell, right? Okay. Now inside the cochlea, there are three empty channels. Well, not empty; they're actually filled with fluid. For simplicity, I'm only gonna draw two of them. Okay, so it's gonna be like that. There's a tube right here at the top. It's gonna be filled with fluid. You know what? Why don't I draw it in color so you can distinguish it? Okay, so there's a tube at the top, goes all the way in. Okay, and then there's going to be another tube right here. Yeah. So like, you know, if you take a slice of it from here, you don't have to draw this, but if I take a slice from there, you will see, you know, the top and the bottom. Okay, if you take a slice here, it's going to be like a thinner slice, okay, because it tapers off, and it's going to be like this, you know. So it's the same thing all the way down. You know, if you had sushi before, it's like a roll of sushi. You cut it up, every piece looks the same, right? Okay, or like cinnamon roll, right? So that's what the setup is like. All right. Now if you roll this whole thing back up again, you get the whole cochlea, and that's what this picture is trying to show you. Right? You see? Right? You have the top canal that I was trying to draw for you, and then you have the bottom one, right? Like that. Right? So imagine unrolling this thing into the whole tube. Any questions about the picture? Okay. So over here, this is where the oval window is. Oval window. And then, you know, down here, that's where your round window is. So of course, you're gonna have your stay piece pressing on it, right? Stay piece pressing on the oval window. Right? So I'm gonna draw it right here. That's the stay piece. Of course, it's connected to the other three bones, right? The anvil and the hammer. Right? These are the ossicles. Now, these canals are filled with fluids. Okay? The fluid is very similar to, you know, like our lymph. I remember lymph from earlier units. So this is what happens when I'm talking to you, when I'm making sound. You know, you hear what I'm saying. The sound goes into the ear, causes the tympanic membrane to move. The ossicles will move. As the ossicle moves, the stapes will push, right? Push into the fluid inside the cochlea. Yeah, so basically, the whole cochlea is kind of like a bony structure, but the oval window, it's kind of like a membrane. So it pushes in, the stape pushes in, then the sound is gonna go through the liquid. The shock wave is gonna go through the fluid inside this top channel. And depending on the pitch of the sound, okay, like high pitch, low pitch, depending on the pitch of the sound, it's gonna turn back. Right? It's gonna turn back, and then the pressure is gonna be released from the round window. Okay, I really need you to visualize this. Okay, I'm sorry, it's really hard for me to show, but you push the red thing in, right? You push the red membrane in, physically pushing it in, because it's filled with fluid inside. Then the pressure is gonna go up, right? The pressure is gonna go up. So where does that extra pressure go? Well, the round window has to bulge out to relieve the pressure, right? Essentially. So relief tension. Right? I have a loose analogy for you to understand this, maybe. I just thought of it. Hold on. Uh, I don't know, probably not the best, but I saw a water bottle here. Okay, so you see on my water bottle, can you actually see that there's a dent here in the water bottle? Look, right? A dent, right? That's kind of like the round window, okay? So when I squeeze on the rest of it, the pressure in the bottle is gonna go up, and then it's gonna cause it to pop out, right? You see that? So when it relaxes, it can go back in. So this is the round window, and then I'm gonna push on the oval window, push down, and then the round window pops out. Do you understand? So whenever red goes in, whenever the oval window pushes in, the round window has to pop out to accommodate for the excess pressure so you don't damage the cochlea. Thumbs up, guys. You get it?
Is it connected somewhere in between?
It's not connected. I mean, sorry. You mean are the windows physically connected?
Yeah.
No, they're not physically connected. But then inside this whole thing is fluid, right? So just like the water bottle, like this part is not physically connected to this part. But when I push in here, the pressure is gonna get transmitted through all the liquid inside, and then the liquid's gonna be pushing the round window out, right? So it's the fluid inside that's passing on the pressure.
Okay.
Now, between the top and the bottom channel, there is a third channel in the middle, right? And just to keep it simple, in there is where you will find the hair cells. Remember the hair cells, guys? These are the mechanoreceptors, right? Okay, so you will have hair cells all the way from the beginning to the end. Okay, I'm not going to draw all of them. Right, so these are hair cells found in a structure called the organ of Corti. Organ of Corti. Okay, organ of Corti. Now, so when the sound goes in, again, depending on the pitch, it's going to turn around differently. Okay, so when it turns around, say over here, then these hair cells will be stimulated and it will send a signal to the brain. Okay? For another sound, okay, sound that are lower pitch tend to go deeper into the canal. Okay, so this is lower pitch, so it goes all the way before it comes around, and then comes, oh my goodness, and then comes out like that. Okay, so this is like lower pitch sound, goes deeper. Right, so that hair cells over here will get stimulated, and then this is like higher pitch sound, turns around, earlier, I guess. I'm not sure what the right word is. So this is what I want you to visualize. Okay? The hair cells here, all the hair cells that you see that are in the middle, they are like the keys of a piano, okay? So when you pick up a sound, like a low pitch sound, like a okay, so it's gonna go in, and then it's gonna turn around. So you're pressing on the keys of the piano that are low pitch sound, and only those keys will be pressed. Only these hair cells will be stimulated, and they send it to your temporal lobe, and you're like, oh, that's a low pitch sound. If you have a high pitch sound, like like that, so go deeper into the cochlea before it turns around, then you are pressing on the hair cells that are deeper in. Right? So when that signal goes to the brain, you register it as a high pitch. Right? So of course, at any given time, it's not just like one pitch that you are picking up, right? Like it's multiple sound, multiple hair cells, all these things becomes an electrical signal that goes to the brain, and then your temporal lobe is going to basically decode that and help you make sense of what is it that you're listening to. Of course, in the temporal lobe, you also have the Wernicke's area, right? Remember that? The Wernicke's area helps you interpret speech. So if the sound that you're picking up has any speech component to it, like now, it's actually going to the Wernicke's area as well. And, it helps you understand what the person is saying. Excuse me, any question at all from anyone? Do you guys understand this setup here? It's not the best explanation. It's very difficult to do it virtually. But anything you want to ask to make this a little bit better? Okay. Well. So the semicircular canal, right? We talked about this already. We have 3 of them. We have the anterior one. Okay. You will stimulate the anterior one if you do somersault. This kind of rotation. You will stimulate the lateral when you do the pirouette. Okay, so like this kind of rotation, as opposed to like that, like a wheel, like this one. And then you have the semicircular canal at the back, like that. That is the posterior one. Okay. And you have to do cartwheel to detect it. I mean, it doesn't have to be the full body rotation to stimulate them. If you just rotate your head, right? Rotate sideways, side to side rotation, lateral. Up and down, that's gonna be the anterior. And if you tilt it to the side, that's gonna be the posterior one. Okay. So on the test, I probably will give you some of these pictures and ask you which semicircular canal is gonna be activated. Okay, so basically they also have fluid inside, and when the fluid moves in those tubes, the hair cells are gonna be stimulated in that tube. The hair cells are actually located at the base of the tube, to be more correct. Okay? So sometimes, like we've all done this, right? Like when we're younger, when we're kids, maybe, or maybe your kids do this. If you spin many times, and then you stop, all of a sudden, you feel like you're still spinning. You feel like the room is spinning, right? And you try to walk straight, you're probably gonna fall down. Right? That's because after you spin so long, and then you stop, the fluid in the semicircular canal, in the lateral one in this case, it doesn't stop right away. It will still spin for a little bit more, and it will continue to stimulate your hair cells. Okay, so then your hair cells will tell you that you are still spinning, but your eyes are telling you that, hey, I'm not spinning anymore, because I'm looking at I'm looking straight ahead. Right? When there are these conflicting information going to the brain, that's how we get disoriented. And this happens in the car. It's more severe for some people than other. If you are able to, look at your phone or read in the car without getting motion sickness, then that's a good thing. But for those of us who get motion sickness, it's because our semicircular canal as well as the vestibule is telling us that we are moving. Right? The car is accelerating and so on and so forth. But your eyes reading the text on the book, right? It's not moving, right? So the eyes is telling you that you're stationary, and you have these conflicting information going to the head, and yeah, and you get dizzy. Okay. Vestibule detects acceleration of the body. Okay. There are 2 parts to it, right? We already label it. There's the utricle, which you can't really see in here, but the utricle is the one that's right here, that's higher up. And then there is the saccule. Okay. So utricle is for horizontal movement. And then saccule is for vertical movement. Okay. Semicircular canal for rotation. The vestibule is just for linear movement, either front back or up down. Okay. So of course, if you think about the person doing like a jump like that, it's just hopping forward because there is movement in both the y and the x direction. Both the utricle and the sacral will be stimulated. Okay. If you're doing the whole rotation as well, like if you jump into the air and then do like a somersault at the same time, both the utricle and the sacral will be stimulated, but as well as your anterior semicircular canal. Okay, that's it. This is like a summary of all the stuff that's going on. I don't know why it looks a little bit off on mine. But you can reposition it. I think I didn't like what was written in there. Like it's like a little bit too complicated, so I change it in a way that matches with what we were talking about in the class. Okay, so like if you have the PowerPoint, just ignore the original writing, I guess. Instead, look at what we have over here. Okay, just lastly, there is interesting condition. I wouldn't. It's not a disease. I wouldn't say it's a disease. It's a condition. Okay, where the person has sensory pathways that are merged together that normally shouldn't merge together. And so when they pick up one sense, like hearing, they would simultaneously perceive it as one or more additional senses, like sight. Okay. So how do I explain this? It's like if they hear if they hear certain sound, like if they hear like a C note, okay, um, at the same time they might be visualizing triangle in their head. Okay, like oh, when they hear the sound, they're oh, this is a triangle shape. Okay, but sound shouldn't carry any shapes, right? But for these people, because the pathway merge together and go up to the brain and stimulate at the same time, they associate these different things. They perceive a single sense as multiple sense. They might be looking at a letter, like they're looking at the letter A, and they could literally taste like sweetness. Okay, the A is sweet, okay, and B is bitter, like literally, because again, the sight pathway going up somehow get merged with the taste pathway, and when they see one thing, multiple things are stimulated. It depends on which pathway is merged together. The outcome is very, it's like a very individualized thing. Okay. So people with in one form of this condition, the person would see each letter with a different color, even though it's black and white. They would see color to them. And so there is a website here which you can try it out, I guess, for fun. Let me see what's gonna open up. So it's like, type in your name. So I can type in my name. So that's what my name is. If a person with this condition read my name typed out in black and white, they would see this color. Okay. V is like, this dark blue color. Okay, I is white, and so on and so forth. So you can type your name in and see, what it appears to be for someone with this condition. So take a look at here. Can you find the twos? Right. There's a bunch of fives here, but there are twos here, right? I mean, you probably will be able to find it. Right? It's gonna take some time, okay? However, for someone with the condition, they would see it right away because the fives and the twos are different colors to them, okay? So that's actually pretty, unique skill set, I suppose. It would have a certain advantage in some conditions, some in some situations. I mean, okay, which of the following presses on the oval window? What do you think? Okay, most of you got it right. It is the stapes. How about this one? Okay, so here it is. I don't know if you wrote it down last time, but saying no, right, shaking the head side to side, that's going to stimulate the green one, right? The green one is the one that's parallel to the ground. Right? So when you move the head sideways, it's going to stimulate that one. So the answer is lateral. Okay, lateral. C. How about this one? Oh, forgot to relaunch the poll. How about this one? Okay, so this is like a linear acceleration, right? Horizontal acceleration, braking. And then the answer is going to be the vestibule. Okay, specifically, it's going to be the utricle as opposed to the saccule. Okay, saccule is for vertical, right? And that's all. That's all for lecture, what is this, number 7, right? So your test is gonna be 6, 7, and 8. And I already told you we will have to postpone. We'll have to postpone the test, right? Okay, because we haven't finished this stuff yet. So let's start on the digestive system next. Digestive is very straightforward. We only have about 53 slides. And I think we should start by labeling some of these things so that we have an idea of where things are. So please go find the study guide. It's right here. I need to get some more water. I'll be right back, but do go find this diagram, please. Okay, let's go through this thing here. The digestive system. Like I said, it's not too difficult. It's gonna be if you survive the nervous system stuff, it's gonna be a breeze. Yeah, but hold on, it's not letting me. It's not letting me choose the colors. Try that one more time. Okay, this is another diagram. I like this one better. Okay, so let's start with some basic terminology. We have from the mouth all the way to the anus. It is called the GI tract. Okay, the gastrointestinal tract. But it has another name. It's also called the alimentary canal. That is from mouth to anus. It's a continuous tube, right? In one way, out the other. And along the way, we have accessory organs. It's in the notes, so you don't have to write down the accessory organs, but they are organs that are going to add secretions along the way to the GI tract. Right? The food don't go into the accessory organs, but we still need the accessory organs to help process the food. Okay? So an example of an accessory organ would be like the liver. Food does not go into the liver, but then the liver helps secrete things like bile to break down the food. Okay, so let's start with the head here and see what we can see. This one is just mouth. Mouth, if you want to be fancy about it, is oral cavity. And obviously, that's where you put the food in. What do you think that one is? People are always surprised to see this like so big in the mouth. They don't expect that. What is that? That is actually the tongue, right? So the portion of the tongue that you see is actually really small portion. The whole thing is quite big. It's a very strong muscle as well. Right? So that's the tongue. This is the nasal cavity, in case you're wondering. Not part of the digestive system, of course, but the mouth and the nasal cavity is separated by the hard palate. And you have 3 pairs of salivary glands. Right? They secrete saliva for you, and those are accessory organs. So here you have one next to the ear. It's called the parotid. Salivary gland. You have one underneath your tongue. Underneath is sublingual. Lingual is tongue, right? Underneath the tongue, sublingual. Like if you are bilingual, you speak 2 tongues, 2 languages, right? So that's underneath the tongue. If you ever go to the hygienist, like the dentist, right? They have to basically use the tube to suck the saliva that's coming out of the sublingual salivary gland. You have another pair right here, where my thumb is. That is the submandibular. Submandibular salivary gland. Okay, so these are accessory organs. Why don't I put a star here, and I will star all the accessory organs for you. Okay. The food does not go into the salivary glands. but we need the salivary glands to secrete the saliva, which will help us process the food. Okay. There's a little thing right here that's dangling at the back. Does anyone remember what that is from earlier units? Respiratory unit, maybe? What is that? Starts with a U.
Uvula.
That's right. Thank you. All right, so the uvula seals nasal cavity. To be more precise, it actually seals the nasopharynx during swallowing, so the food does not go up to your nose. Okay. This is the back of the throat, which you should know it's the pharynx. Common passageway for food, for liquid, and for air. All right, what have we got next? This tube right here. You know this one, right? What is that? Okay, it runs parallel to the trachea, and it's posterior to the trachea. Connects the pharynx to the stomach. That would be the esophagus. Okay, some people spell it with an O at the front, but esophagus is fine. Now we have a diaphragm here, and that there's actually a hole here. There's a hole in the diaphragm called the esophageal hiatus. It's like a little break in the diaphragm for the esophagus to go through. A hole in the diaphragm for esophagus to pass through. Okay. That's all. Okay, further down. We have this guy right here. What is this? You should know this, right? It's on the right side of the abdomen. The liver, that's right. Thank you. That is the liver. There we go. A liver is an accessory organ. Of course, the liver helps detoxify the blood and makes the plasma protein and a bunch of other stuff. But in the context of the digestive system, the liver produces bile. Okay. Now you can't really see it in this particular picture. I mean, it's here. Okay. There's a little pouch here. Okay, and then I'm gonna use dotted line to show you like it's actually connected behind, like it's actually located behind the liver. Like you have to lift the liver up a little bit to see it. And this little thing, it's actually green, and like for real, it's green. in real life. And anybody know what that is?
Gallbladder.
That's right. That's a gallbladder. Some people can have stones growing in the gallbladder if the cholesterol in the blood is too high and you have to remove it. So the liver produces bile, but the gallbladder stores bile. I'll tell you what bile does later on. Okay, bile is very bitter. Okay, moving on. We have the stomach here. I don't know what the best way to do this is. I guess we'll just outline it. There's the stomach. Okay, on the upper left quadrant of the abdomen, right below the diaphragm. Right there is the stomach. Right there. Oh, sorry. Gallbladder is also accessory organ. Stomach. Okay. Contains acid. Right? Contains HCl to break down food. Right? Okay, there is this one right here. It's not part of the digestive system, but I guess they just put it here for completion's sake. We learned this before. Anybody know what this guy is?
Spleen.
Yes, thank you. Very good. That is the spleen. It's part of the lymphatic system. Doesn't really have anything to do with the digestive system, but that's where the spleen is, if you're wondering. Okay, there's another guy here, which is behind the stomach. It's behind the stomach. It's right here. Anybody know what that is? It's behind the stomach. And it has all these like bumpy knobs on it. Anyone? You need this to make insulin. Does that help?
Pancreas.
That is the pancreas. Very good. It's behind the stomach, all right? It's a little bit protruding here. So pancreas, yes, it makes insulin, but that's not the function in the digestive system. Okay, the pancreas, as you will see, makes digestive enzymes. I'll explain when we get to the PowerPoints. And NaHCO3. If you remember your chemistry, you should know this is sodium bicarbonate. Right? So it's going to help neutralize the acid from the stomach, right? Okay. Now, it's very important to make sure things goes forward in the GI tract. Anytime things starting to come backwards is going to be miserable for us, right? Like, think about vomiting. If it hurts, it's unpleasant, right? It's gross. Things going back up, right? So we tend to have these sphincters that keep things from coming back up. Sphincters is the equivalent of a valve in circulation, right? So there are various sphincter here. There's one right here. Okay. This is called the cardiac sphincter. It keeps the stuff in the stomach. Okay, but of course, if a person needs to vomit, then it forces its way through the sphincter and then it comes out anyway, right? But normally it keeps the stuff in the stomach. It's not going to come back up. But some people have a loose cardiac sphincter. Certain food is going to make it a little bit, loose, makes it relax. And the acid content is going to come back up and then it's going to burn the esophagus, right? A little bit. When that happens, what condition do we have? It's very common. It's not like a serious condition. People can take some Tums and make it feel better. What am I talking
Heartburn.
about? That's right, the heartburn. Right? So a heartburn is basically the cardiac sphincter not really closing properly, and then the acid's kind of coming up. Similarly, we have another sphincter down here that keeps the content of the stomach from moving forward when it's not ready. Excuse me. So, it keeps it there, make sure you digest it reasonably well before you let it pass forward. And that is running out of space, but it's pyloric sphincter. We will have notes on these things, okay? I just want to tell you where they are first. That's the pyloric sphincter. Okay. So basically, the sphincter at the top, sphincter at the bottom keeps everything in the stomach. All right, so I'm gonna switch color for the next part here. And I suggest you do the same. The small intestine is next. Okay, small intestine. The small intestine is actually really long. It's like, 6-7 meter long, depending on how tall the person is. And it's separated into 3 parts. Okay. So the first part is right here. And let me try to use different shade of green here to show. So that's the first part, directly connected to the stomach. You can't really see it, but you have to believe me. It's going to be behind. It's going to be behind the large intestine right there. It's going to go behind it. And that's the first part of the small intestine. Okay, they don't have a label for it, so we just have to add our own. Okay, that is called the duodenum. Okay, so do it in a different color so you know it's part of the small intestine. It's not too long. This one is about, 25 centimeter, 12 inches long. Okay, so it's the shortest part of the small intestine. Okay. Then the small intestine, it's going to transition. The duodenum is going to transition into the next part, which is a little bit hard to see here, but we'll roughly say it there. And then it's going to go to the last part. It's all kind of jammed up into the abdominal cavity right here. Okay, so the second part of the small intestine, which we also have to have a label here, is called the jejunum. Jejunum. My favorite name in the whole anatomy course. Jejunum.
Excuse me, sir.
What's the question?
So which one is the transverse colon? Is it the duodenum?
No, the transverse colon we're not there yet. It's this thing right here. Okay, but we're gonna get to it. That the transverse colon is part of the colon, which is part of the large intestine. Okay, but the duodenum goes behind the transverse colon.
Oh, yeah.
And then after the jejunum, it's gonna become the ileum. Okay, so all these green things that I just labeled, they are all part of the small intestine. Duodenum is for digestion. Jejunum and ileum is for absorption of nutrients. Okay? Then we're going to move on to the large intestine. And I'm going to do like different shades of blue every time we change the section. So the first part that comes off is this big part right here. Okay, that we also have to add our own label, is the cecum. Cecum. It's the first part of your large intestine. Now, of course, there's a thing that dangles off from the cecum right here on the lower right side. What do you think that is? You must have heard of that before.
Appendix.
That is the appendix, that's right. Now, we don't know what the appendix do. It might have some function in the past, but it doesn't really do anything nowadays. Okay? We call it like a vestigial organ. A vestigial organ is something that had function before, like in evolution, but no longer have any apparent function in modern days. Some speculate it has something to do with immune system, but you can live without it. Okay, the appendix might swell up, and you have to cut it out before it bursts. Once it bursts, it's really bad for us. Okay, I'm gonna switch to like another blue here, maybe. So after the cecum, we're gonna go up. Okay, like the food is gonna go up, right? I mean, by this point, it's not really food anymore. It's just like most of the nutrients have been absorbed. By this point, it's just mostly water and waste products. And that is the ascending colon. Okay, next we're gonna move sideways. Okay, we're gonna move sideways. Maybe we're just gonna erase that arrow right there. There we go. Okay, we're gonna move sideways. Let me switch to another color. Okay, very busy diagrams, very sorry. But that would be the transverse colon going to the side. Right, so food goes up to the side, and it's gonna come down. It's gonna come down afterwards. Okay, what is that? Well, if there is an ascending colon, you can bet that there is a descending colon, right? So we'll just use this line here, descending colon. So all these blue stuff, that's part of the large intestine. The green, those are the small intestine. Okay, there's this thing here. That's the sigmoid colon. Just for it to go sideways. And we have the rectum. This is where you store the poop before it comes out. And finally, the anus. All right, I have two more things to add here, and then we're gonna have a break. There's another sphincter right there, another sphincter. We definitely want to keep like the poopy stuff in the large intestine so that it doesn't go back to the small intestine, right? It's gonna cause an infection otherwise. So there is a sphincter between the ileum and the cecum. It's called the iliocecal sphincter. Okay, it prevents the large intestine content from moving backwards. And then we have two other sphincter here at the anus. There is the internal and external anal sphincter. Okay, so like we can hold it. Right? Like we know when to go. If we need to go to the bathroom, we can hold it until we're at the bathroom, right? Kids, they like, you know, when I say kids, I mean like, you know, kids under 2 years old or a year and a half, they can't, okay, because they don't have control over the sphincter yet, as you will see. All right, so there you have it. Those are all the glory details. I think I missed a star here for the pancreas. That is also the accessory organ. So why don't we take a quick break? Let's come back at 9:45, okay? And then we will go through the PowerPoint slides. Okay, I'll leave the screen on this diagram. All right, thank you. See you in a bit. All right, so let's keep going. We're gonna switch to the PowerPoint slides now. Like I said, it's a short lecture. Maybe we'll be able to get through all of the slides. We'll see. Okay, digestive system. What you see here are bacteria that's called H. pylori. H. pylori. It's estimated that 1/3 of the population has H. pylori in them, although most of them are dormant, so you might not know you have it. But they are the bacteria that causes ulcers, which previously people thought it's related to stress, but not necessarily. It's actually caused by this little bacteria that can bury themselves in the mucus of the stomach lining, and therefore the acid cannot get to them. Okay, function of the digestive system. It's very obvious. It's for you to ingest the food, break down the food into small molecules. So, you know, all the macromolecules that we learn in the first semester, you know, the digestive system will break the proteins into amino acids, and then to absorb it, it will break the lipids into, say, the fatty acids, and you'll be able to absorb it. And whatever you cannot absorb or digest, we're going to eliminate it as waste product. As I told you earlier, the digestive system has two major division, if you would. There is the alimentary canal, also known as the gastrointestinal or GI tract. And that is starting in the mouth and going through all the stuff that we've labeled before the break, and it's going to exit through the anus. Along the way, there are accessory organs that secrete various mixtures into the GI tract. So the salivary glands, the liver and the gallbladder, the pancreas, all these are accessory organs. Okay, they add various mixtures to help digest the food that is passing through the GI tract. So the GI tract, the alimentary canal, actually has 4 layers to it. Okay, 4 layers to it. So starting with the innermost layer, this is a layer where the food is directly touching. Okay, we call that the mucosa. Mucosa. It's a layer of epithelium. We learned about epithelial tissue last semester. And depending on which part of the GI tract we're talking about, the type of epithelial tissue is going to be different. Some parts are going to be squamous, some parts going to be columnar. It really depends, and I'll go through them with you as we get to those parts. But it's epithelial tissue supported by connective tissue that lines the lumen. By now, you should be familiar with this term, right? The lumen. The lumen is just the inside of a hollow structure. So, you know, if this is the intestinal tract, the inside right here, that is the lumen. It's the same word we use when we describe the inside of a blood vessel, right? So that's that. And it's responsible for most of the digestive, absorptive, and secretory process. Digest is obvious. It means it breaks down the food. Absorb the nutrient. And secretory means sometimes we have to secrete some kind of mucus, some kind of acid in the stomach, for example, right? All these things where it involves secretion of some kind of stuff, that is also happening in the layer of the mucosa. Right? So even though we are receiving secretions from the accessory organs nearby, the GI tract itself is capable of making some secretion by itself. Outside of the mucosa, we have the submucosa. Okay? This layer contains blood vessels, lymphatic vessels, as well as nerves. Okay? The nerves do two things. Number one, it controls the movement of the GI tract. Do you think this is sympathetic system or parasympathetic system for the GI tract to move? Sympathetic or parasympathetic? Forgot most of that stuff, eh? Sympathetic is for fight or flight, right? And parasympathetic is for when you are relaxed and you know that's when you're going to be doing your digestion. So the stimulation of the GI tract, it's going to be through the parasympathetic. Okay? And that's what these nerves are. It's going to carry those signals to the GI tract and promote its movements. Right? It also allows you to feel your gut a little bit as well. Like sometimes you can feel the movement of the content in your GI tract. Right? There are also some special lymphatic nodules called the Peyer's patches, and they're there to basically survey the content of your small intestine specifically, and to see if there is anything bad that you have consumed, and you know if you ate something bad, then you might get upset stomach or diarrhea, but something has to pick up that that pathogen to begin with, and that is part of the job of the Peyer's patches. So mucosa is the innermost layer, submucosa is the layer outside. Then we have the muscularis, Okay? Muscularis is, as the name implies, where the muscle is going to be. Okay? These are smooth muscle. We don't have voluntary control over our intestinal tract. The ANS, the autonomic nervous system, takes care of it for us. And the GI tract has two layers. There is the inner layer, which is made up of circular muscle. So the it's hard to draw this out, I suppose, but we can try. So this is the GI tract, and the circular muscle basically goes like this. Okay, circular. And the circular muscle is responsible for like squeezing, opening, right? And then the outer layer, outside of the circular layer, is going to be the longitudinal. Okay, longitudinal means it runs parallel to the length. Okay, longitudinal. Okay, which is outside of the circular layer. So, you know, this is the tube, right? If it goes sideways, longitudinal does this kind of motion, stretches and squeeze, stretches and squeeze. So together, the circular and the longitudinal, basically they squeeze and push, squeeze and push. That's how you propel the food forward. Okay. And then for the stomach, there is an additional layer. Okay, the additional layer is oblique, it's diagonal, and it's going to be deeper than the circular layer. It's inside the circular layer. So not only does the stomach have the squeezing and the stretching motion, but there's also a little bit of twisting motion as well. So the twisting from the oblique allows you to kind of mix the content a little bit. It's more like a washing machine, right, if you would. And finally, on the very outside, we have the serosa. Serosa is very thin. It's made up of squamous epithelial. Squamous is the flat cells, right? And it basically secretes like a lubricating fluid called a serous fluid to keep the surface of the GI tract moist. Because when the food is moving through the small intestine is kind of like rubbing against each other. And in the diagram, you can see the large intestine and the small intestine are very close together. So anytime the thing moves through each other, you don't want there to be friction. Okay, friction is going to cause wear and tear and pain, right? So then with these serous fluid, and make sure everything's going to be sliding past each other quite easily. So there is a diagram to show you the different layers. This is a cross section of it, and you can probably make out what it is that we are seeing. So for example, the very deep purple color right here, this part that I'm coloring here, you can trace it all the way out, right? That's the deepest layer, the mucosa. And as you can see, it's actually not a smooth interior, right? It's all folded up so that it gives room to expand when there's food passing through, right? It also increases the available surface area. Now, beneath the mucosa, we have the submucosa, which is right here. It's this light blue color. Right, this whole thing outside. And there is the outer edge of it. Okay, so like between the red lines, that's where the blood vessels, the lymphatic vessels are going to be, right? And the nerves. Outside of that, you have the muscularis. Okay, muscularis. This is not the stomach, so you only have two layers. The first layer is this one right here. That's the circular layer. Okay, and then you have the longitudinal layer on the outside. And here they have something called the adventitia, which it's same as the serosa, right? Really. For us, it doesn't matter. So you have 4 layers from the mouth all the way to the anus, except for the stomach. There's an additional muscularis. Okay, I'm just gonna skip through the polls here. But blood vessels, lymphatic vessels, and nerves, if you have been listening, you probably know it is the submucosa. Submucosa. B. All right, let's move on from the mouth to the stomach. A human produces over 1 liter of saliva every day. That's a lot of saliva. Most of them we just swallow so that we don't get dehydrated, right? Mouth begins physical and chemical digestion. Chemical and physical digestion is the same kind of definition as chemistry. You have physical and chemical change. Physical change is not changing the substance itself, right? So in this case, it's like chewing your food, breaking it down into smaller pieces. Okay. Breaking food down into smaller pieces. Okay. Like eating a carrot. Take a bite and then you keep on chewing it and it becomes smaller pieces. It's still carrot in the end. You're not changing it. Chemical digestion is when you actually do a reaction. Okay? You will break down some of the carbohydrates, as you will see, and converts it into glucose. The mouth has a roof that separates it from the nasal cavity. We know this already. It's the hard palate, right? You push your tongue up, it's hard, and that is the hard palate, which is formed by the 2 bones, the maxilla at the front and the palatine bone at the back. Don't worry too much about these at the moment. We'll learn the bones when we get to the bone unit. Yeah, but I'll show you quickly. Okay, this is looking at the mouth from below. Okay. this here, this whole thing, that's the, actually, this whole thing, right? Not including the teeth. If you remove the teeth, but this whole bone is the maxilla. It forms the roof of the mouth, the front of it anyways. And it also provides socket for your teeth to go in. And further back, right here, that is where you have the palatine. Palatine. Right? So together they form the hard palate. Okay. Still further back, this is where the soft palate is going to be no bone. It's just glandular tissue. And then the uvula is going to be right here at the back, right? Okay, so soft palate is formed by muscle and glandular tissue, and it ends with the uvula, which, as you know, seals the nasal cavity, so the food doesn't go up. Okay, teeth. The act of chewing has a fancy name. It's called mastication. And kids, they have 20 baby teeth or deciduous teeth, but then they fall out, and then adults have a total of 32 teeth. Depends, right? Some people don't have their wisdom teeth, so you end up having less. And some people, they have wisdom teeth that comes out sideways, and then they have to remove them. We have the incisors at the front, right here. Those are the incisors. Those are for biting. Okay, biting, incisors. And then we have the canine. The canine are the pointy ones. Okay, so there is the canine. I mean, it's not that pointy, but it's basically like in dogs, it's really pointy, right? Those are the canines. And those are for tearing. If something is really chewy, you tear it off with the canine. Premolar and the molar, those are for grinding the food and crushing the food. Okay. So you chew off, again, whatever it is, the burger, and then you're gonna move it to the back and bite it some more, grind it down before you swallow it, right? There are 3 pairs of salivary glands. We labeled those already. There's one next to the ear, the parotid. Underneath the tongue, you can probably see that one. Like if you curl your tongue out, you can see the opening of the gland. It's like a little bit darker coloration. That's where the saliva comes out. And you also have your submandibular gland. So together, they secrete 1 to 1.5 liters of saliva every day. Now, saliva is quite useful, but it's mostly water. Okay, mostly water. It contains a little bit of amylase. Okay, so I don't know if you remember, but amylose is basically a long chain of carbon. Okay, long chain of carbon like that. That's amylose. And when you expose it to amylase, you either break it down into maltose, right, or glucose, or some short polysaccharide. Okay, so like basically, like these are drawing is getting worse and worse, but basically this is amylose, is long chain of glucose, and the amylase will chop it up. Right? It might chop it up into individual glucose. It might chop it up into like short chains. It might chop it up into maltose. Just cuts it up a little bit. So the chemical digestion of carbohydrates actually begins in the mouth, whereas everything else kind of comes later on. Okay, the digestion of protein, digestion of lipid, that happens later on in the body. Saliva is also important to moisten food. It's actually very difficult to swallow things that are dry. Okay, it's very prone to choking as well if we don't have food that are moist. And we learn in Unit 3, Lesson 3, that saliva contains lysozyme and some antibodies. And that helps to control the bacterial growth in the mouth. You might have heard of this before. There was a time where there's something called a cinnamon challenge in on the internet. People do all sort of weird things online, and it's to try to swallow a spoonful of cinnamon. Cinnamon is actually very dry and it sucks up all the saliva. And what happened was there was a kid who tried to do this, and basically it was so dry that it gets stuck in his airway as he was trying to swallow it, and he choked, unfortunately, and died. And this illustrates the importance of having saliva. Right? It moistens the food, so it's easy to go down. If it's super dry, it might end up going down the wrong tube, and causing us to choke. Okay, when we do swallow, the tongue actually rolls the food into a ball, and the ball is called a bolus. Bolus is basically a ball of food. You push it back to the back of the throat. It triggers the swallowing reflex. You might remember the swallowing reflex is performed by the medulla oblongata, and we're going to swallow it down the esophagus. And during swallowing, the larynx moves up against the epiglottis to seal the glottis, and at the same time, the uvula closes the nasopharynx. Nothing is new. We know all these things already. So there's the bolus going down, and the do I have a? Oh, there it is. Okay, so the food goes down the esophagus. As you know, the esophagus connects the pharynx, the back of the throat, to the stomach. And there's the diaphragm. And when we were labeling it, I told you there is a hole in it called the esophageal hiatus that allows the esophagus to go through. Now, the esophagus needs to have very resilient epithelial tissue. It's multiple layers of flat tissue. So we call those stratified squamous. And the stratified squamous is going to protect the esophagus from the hot and the cold temperature of the food. There is some abrasion because sometimes the food we eat it's kind of rough in texture. Like if you think about eating chips, right? Like it's actually a little bit pointy, and when it goes down the esophagus, we want to be able to protect the lining from cuts and stuff like that. So these stratified squamous, it's very suitable for that, as well as chemical exposure. Okay, the food that we eat might be acidic, it might be spicy. All these chemical exposure can lead to wear and tear of the esophagus, and so you need to have multiple layers of these squamous epithelium to protect the lining. Okay, so when we are not swallowing, the esophagus is collapsed. Unlike the trachea is always open, right, because of the cartilage ring. But for the esophagus, it's ordinarily collapsed, and it only opens when the bolus is going down, when we're swallowing. The food doesn't just fall down into the stomach, okay? You actually need to push the food down, and that's where the muscularis is going to come in. There's the squeezing motion, and then there's the pushing motion. Circular muscle will squeeze, and the longitudinal will push, and then the bolus is going to go down. So these rhythmical squeeze and push, they create these wave-like contractions, and we call it peristalsis. And that is the kind of movement that propels the food all the way through your GI tract. Okay. So you can actually swallow upside down. And food doesn't actually, fall down, right? It gets pushed down. It's like if you think about a stocking and you have a tennis ball, You gotta push the tennis ball through. Right? It's not just gonna fall down. So at the end of the esophagus, it's gonna go to the stomach, and there is a sphincter there. We label it as, excuse me, we label it as the cardiac sphincter, but sometimes it's also called the lower esophageal sphincter because it's at the bottom of the esophagus, right? The cardiac sphincter is fine. So there was a article I saw. It says the you know there are these people who participate in pepper eating contests. If you've never seen one, you can search these things up on YouTube. And ghost pepper is the hottest pepper, one of the hottest pepper that exists. Okay, people actually breed this pepper themselves, pepper plants themselves, and make it harder and harder. And it was so hot that the person who ate them end up burning a hole in the esophagus. So remember, the esophagus has the stratified squamous, right, to protect yourself from all these exposure. But when it's like way too hot, right, you just can't withstand it, and then end up ripping a hole in the esophagus, and the guy had to spend 23 days in the hospital after eating these super hot pepper. And so when it comes to the hotness of these pepper or anything that's hot, there is actually a chemical in it that's responsible for creating these hot sensation. It's called capsaicin. Okay, so it's not a taste, right? I told you in the lecture 6, spiciness is not a taste, but rather it's like a sensation. So when you bite into these hot stuff, the capsaicin turns into like a fine spray, and it basically triggers the heat receptors that are in the mouth. Okay, it's the same kind of heat receptors that you have on your skin. So those heat receptors, things that you are being burned and that you are being overheating. That's why when you eat spicy stuff, you end up like sweating, right? And you end up feeling all warm, right? That's your brain responding to the heat. Okay, it's the same kind of mechanism that your body would have when you are like literally feeling hot, right? All the sweating and stuff like that. So the capsaicin is can be washed away, if you would, with milk, because there is a protein in milk called casein that will bind to it and then wash it away. That's why if you see people eat like pepper in these pepper eating contests, they always have like a glass of milk next to it. That's supposed to help neutralize the heating sensation when it becomes unbearable. So for those of you who are interested, here's a chart that shows you that rank how hot these things is, and the measurement for how hot something is called the Scoville heat unit. Okay, SHU. So if you like a little bit of Tabasco or Sriracha on your food, those are not very hot. Okay, those are like in the low thousands. But when we're talking about like these very specially bred pepper, in the millions of the scale. Okay, super hot. Okay, what macromolecules begins chemical digestions in the mouth? Well, if you were listening, hopefully you know it's the carbohydrates. You have the amylase that would start breaking them down. Which salivary gland is located next to the ear? Okay, I'll give you a moment to think about that. Which salivary gland is located next to the ear? If you look at the diagram that we label, it's the parotid. What type of epithelial tissue forms the inner lining of the esophagus? As I said several times, because there's a lot of like cold, hot, spicy, acidic stuff that's going down our esophagus all the time, we need to protect it. And the best way for protection is stratified squamous. Okay, moving on. We have the stomach next. Okay, so food typically stays in the stomach for about 2 to 4 hours, depending on what you eat. Right? If you eat oatmeal, it's going to stay there just, a little bit. It's already pretty digested anyways. It's going to be able to move on. But if you have like a heavy meal with lots of meat in it, right, then that has to stay for a longer period of time before you can digest it. But at the end of the digestive process, you will end up having a soapy acidic mixture. That's called the chyme. Okay, chyme. It's nothing mysterious. Okay, like if you vomit the stuff that comes out, that's basically what chyme looks like. Okay, so it's acidic. It's like partially digested food. Okay. I told you the stomach has a cardiac sphincter on top that prevents the food from going back up. There's also the pyloric sphincter that regulates how much chyme can move on to the small intestine. Okay, it's important to release the chyme to the small intestine in a controlled fashion. You don't want to overwhelm the small intestine because unlike the stomach, the intestine does not have mucus lining protecting it. So the acid will burn it if you have too much. Right? So you need to. It's almost like a water gun mechanism. Okay, you squirt a little bit of chyme forward, a little bit at a time. So more on that later. Now, much of what we understand about the stomach has to do with this guy. Okay, there's in the 1800s there is this fellow named Alexis Saint Martin. He's a Canadian voyager. He's traveling from port to port and then do some fur trading and stuff like that. But one day he was standing at the port. He actually got shot by a misfire gun that was 3 feet away, and the shot left a hole in his abdomen and in his stomach. Okay, so there was an army doctor that was called to treat the man at the time, and that's this guy right here. I think his name was William Bermond. So he actually tried to fix the problem, but as time goes on, the wound doesn't really heal. So there's like a permanent opening that was left in his abdomen, and through that hole, the doctor can gain access to the inside of the stomach. Okay, so it's really hard to visualize. It's like the person actually didn't die of an infection or of anything like that. But what's really interesting is the doctor used this opportunity to study the stomach. Okay, so from what I read, he actually would like put food in a little pouch, and then he would stuff the food into the stomach of the guy, and then they would take it out after like 1 hour and then look at how the food has been digested. Okay, so it was said that there was over 200 experiments that were done on this guy on Saint Martin by the doctor, and all these testing led to more understanding of how the stomach worked. I don't know if the work was consensual. I don't know if he got paid, but again, like ethics back then was not really paramount, right? So, but anyway, it's a good story. You can look it up if you're interested. So what's going on in the stomach? Well, when the stomach is relaxed, there are actually a lot of foldings in it, and these foldings they are called rugae. Okay, rugae, and the rugae is going to be disappeared when the food actually goes into the stomach. It's kind of like the wrinkles in a balloon. When the balloon is not blowing up, you see all the wrinkles on the surface. But once you inflate it, it's gone, right? So the rugae, it's the same thing. When your empty stomach kind of move, the rugae kind of rub against each other, and that creates the stomach growling, right? Like when you're hungry, that sound that you make. Uh, as I said several times already, there are 3 layers of the muscle in the stomach. In addition to the circular and the longitudinal, there is also an oblique layer that helps churn the content and mix them well with the gastric juices. Gastric juices is just mostly the HCl. So here is a detailed view of the stomach. You have the esophagus at the top here. There is going to be a sphincter right here. I mean, they don't really show it, but you know it's there. There's the pyloric sphincter at the bottom, and then that would be the first part of the small intestine, right? The duodenum. Now you can see the rugae here, all these linings, all these bumps, those are the rugae. And when the stomach is full, it's gonna disappear. There are 3 layers of the muscle, right? The longitudinal at the front, circular, and oblique. You can see the oblique, it's actually diagonal, right? That's what oblique means. Oblique literally means diagonal. And then you can see, like if you take a slice of stomach, you can see that even though it's bumpy on the surface, but sometimes there is going to be these groove that goes all the way down, okay? All the way down. And located at the bottom of these groove, that's where you're gonna have what we call like a gastric gland, okay? And that's where the stomach acids and some of the other secretions are gonna be produced. Let me go through this with you. Okay, so over here, right, there is one of these groove. The top part is called the gastric pit, and that's where you're gonna have the mucus cells. Okay, mucus cells. As the name implies, the mucus cells are gonna be secreting mucus. And further down, deeper, we have the gastric glands. Right? And there are 2 types of cells in the gastric gland that we're gonna talk about: the parietal cells and the chief cells. Okay, so 3 types of secretory cells. These are cells that can secrete stuff. So mucus cell secretes a thick layer of mucus to protect the stomach lining from its own acid. Right? The HCl is not going to digest the stomach because of this thick mucus layer. Nothing is absorbed in the stomach other than water and alcohol. That's why people say, you know, if you drink alcohol with an empty stomach, you get drunk, like more likely to get drunk quicker, because all the alcohol is being absorbed really quickly through the stomach lining, and you know, without the food there, you absorb it even faster. And at the beginning, I said there's a bacteria called H. pylori. It's able to bury themselves in the mucus lining. Okay, so the acid is not going to be able to kill them. And when your immune system goes down, these H. pylori is going to be able to start to multiply and, you know, basically eat away the stomach lining, and that caused the acid to now irritate the stomach directly, and that's what creates ulcer. So further down, we have the gastric glands, right? And one of the cells in the gastric glands is called the chief cells. And the chief cells secretes what's called pepsinogen. Ogen means it is inactive. And the acid, the HCl, is actually going to activate it and turn it into pepsin. So if you have a protein here, okay, this is protein with all the amino acid and stuff like that. The pepsin is basically going to chop it up into smaller pieces. Okay, so you're doing chemical digestion. Carbohydrates, chemical digestion begins in the mouth. Protein, chemical digestion begins in the stomach. The HCl, the hydrochloric acid, is produced by the parietal cells. Okay, just to go back here briefly to show you, okay? Parietal cells and chief cells, they are deep down in the gastric gland, right? And the parietal cells produces the HCl, which has a pH around 2. That is very acidic. pH scale goes from 1 to 14, right? So 2 is in the acidic end. And the HCl has 3 functions. It breaks down the connective tissue in the meats that we eat. It helps turn on pepsinogen, as I showed you in this reaction here. HCl actually activates it. And it also provides immune protection. Okay? So if there is some like bacteria in the food that you eat, the acid's going to take care of them. Okay, most of the time. Like sometimes they evade, and then it causes you to, get food poison and whatnot. But most of the time, it's going to be there to take care of them, right? In addition to hydrochloric acid, the parietal cell also produces something called the intrinsic factor. Okay, so it turns out we need vitamin B12 in the body. Okay, it's gonna help us with the hemoglobin production and stuff like that. So the vitamin B12, which we can get normally from the food that we eat, the B12 is sensitive to acid, and the acid is gonna destroy it before we can absorb it. So the intrinsic factor is gonna protect the B12 basically. It protects it from the acid so we can absorb it later. Some people don't have intrinsic factor because of mutation, so they cannot absorb the B12, and that could lead to anemia. Okay, so for those people, they might have to take supplements, right? Or they might have to receive injections of B12. Because sometimes even if it takes supplements, it's not enough because their stomach is still breaking it down, right? The problem is not that you're not, taking B12. It's just that you can't absorb it because the acid breaks it down in the stomach, right? So, just to recap, mucus cells makes the mucus to protect the stomach lining. Parietal cells makes the HCl and the intrinsic factor. And the chief cell, they make the pepsinogen, okay, for protein digestion. Okay, so answer is parietal cells. You should do these on your own later on, okay? Like I'm just going through them. What enzyme is produced by the chief cells? Okay, pepsinogen. Okay, moving on. Now we're going to go to the intestines. We're almost there. The small intestine, as I said, is the longest part of the GI tract, separated into the duodenum, jejunum, and ileum. We already labeled it, right, in our diagram. And you can see immediately after the stomach is the duodenum, and it goes behind the transverse colon, right? And then we have the jejunum and the ileum. So there are three features that increases the surface area of the small intestine. It's probably easier if I draw it for you so that you can see it better. Nope, that's the wrong note. Okay. So here we have the intestine. If it was smooth, then the surface area is not going to be enough, okay, for absorption. So that's why the first thing, as you saw earlier, is that there are these circular folds. Okay, so that's the circular fold. That itself is already going to increase the surface area quite a bit. Now we can zoom in into one of these folds, and you will notice on top of the folds, you have even more foldings. Okay, more foldings. More foldings. These foldings, they are called villi. They further increases the surface area. And then if you zoom in into a villi, okay, this is called villus now, singular. They are made up of cells, more cells here. They're made up of cells. And the cells have more foldings on them. Okay, so they are like folds on top of folds on top of folds. These extra folds, they are called micro. villi. Right? So a bunch of folds, all these folds together is going to help increases the surface area of the small intestine drastically. And the reason why we want to increase the surface area is to make it more efficient for both digestions and absorption. All right. So that's what this slide talks about. You can read about it later. This is what it actually looks like. So this here is the circular fold. Right? This is PC here, but it's really just a circular fold. And these things that are coming out, those are the villi, right? The villi. You can't see the microvilli here. You have to zoom in to one of these things, and then you will see the microvilli. But it's there. Okay, you can see this here, it says ME. ME is the muscularis. And then inside the muscularis is the submucosa, right? And then you have the mucosa right here. So the 4 layers, right? Outside, of course, you also have the serosa, which is not shown here, but it's there. Okay, moving on. Chemical digestions in the duodenum. Okay, so remember the 3 parts of the intestine, right? Duodenum, jejunum, and the ileum. The duodenum is where most of the digestion takes place. Once you get past the duodenum, most of the things will be digested by that point. And then the jejunum and the ileum, that's where absorption is going to take place. So in the duodenum, it is going to be receiving secretions from 2 places. Okay? The gallbladder, it's going to be secreting bile into the duodenum through the bile duct. And the pancreas is going to be secreting pancreatic juice through the pancreatic duct. Okay, so 2 things will go, both of these accessory organs will be secreting directly into the duodenum. So what kind of things is going in there? Well, first of all, let's take a look at the bile. The bile is made in the liver, but stored in the gallbladder. And it's secreted directly into the duodenum through the bile duct. And the bile contains, cholesterols. There's a bit of bilirubin in it. That's why it's the yellowish in color. And the function of the bile salt is to take a big chunk of lipid and then make it into smaller droplets. Okay. So this process is called emulsification. It's essentially the same function as detergent. Okay, it breaks the lipids into smaller chunks, and then it can get washed away by the water. Okay, so the bile makes it easier to digest the lipid because it makes it into smaller droplets. Some people have gallstone in the gallbladder, and that tends to be a problem when there is a high cholesterol content in the blood. The cholesterol starts to precipitate out a little bit, and they turn into these stones. It's very painful, especially if the stone gets stuck in the bile duct. Then it's going to be very, very excruciating pain. These kind of pain, of course, is registered through the visceral nociceptor, right, to connect it to previous lesson. I know it's very painful because my dad had gallstone, before, and just looking at him, like it's not, typical pain. It's very, very uncomfortable, and so you have to remove your gallbladder. It's okay to live without the gallbladder, but you would have to watch out to not have greasy food, too much greasy food, because now you don't have a place to store the bile, right? You kind of have to secrete it directly from the liver, right? So it's kind of made on demand. Okay, the liver also do other things, including detoxifying the blood. Right? So if a person consumes alcohol, the liver is going to help break it down, metabolizes it. It stores iron as well as various vitamin. Makes plasma proteins. We already learned a bunch of plasma proteins, right? Albumin, fibrinogen, they are made in the liver. We can also store glucose as glycogen. We learned that last semester. And if we don't have enough glucose, if we skip a meal or something, the glycogen can be broken down to release glucose. Okay? If you are really, really fasting for a long time, then the body, the liver, is going to convert the glycogen. It's going to convert the fat, right? It's going to break down the fat into the glycerol and fatty acid, and it's able to convert the glycerol into glucose. Right, so this process there's a name to it. It's gluconeogenesis. Okay? Genesis is to create. Neo is new. So we are creating new glucose. That's basically what it means. Okay. So, Ramadan is coming up and people might be fasting. And your liver is going to play an important role in creating these glucose during the fasting period to sustain the body, right? Pancreas. Right? Pancreas is right here, and it's secreting pancreatic juice. And the pancreatic juice actually contains two important components. First of all, the juice itself is a mixture of pancreatic enzymes. There are like 28 different enzymes that is in this mixture. I will show you some example. But more importantly, the chyme, by this time is called a chyme now, right? chyme. The chyme is coming from the stomach, but unlike the stomach, the duodenum does not have the mucus. Right? So the acid that's coming in is going to irritate the duodenum unless we neutralize it. And that's what the sodium bicarbonate is for. Okay. The sodium bicarbonate is in the pancreatic juice and it's going to help neutralize the acidic chyme entering the duodenum. So it's a neutralization reaction. Right? I assume you learned these kind of reactions in chemistry. It's going to become NaCl, and then it's going to become H2O and some carbon dioxide. That's why we make gases when we digest the food. Yeah, it's because of the neutralization reaction. So what enzymes do we have? Well, we have enzymes like amylase and lactase. These are not new terms, right? From the name lactase, you should be able to tell that it breaks down lactose. Okay. We already had some amylase from the saliva before. Now you just get more. To break down the proteins into amino acids, we have pepsin and trypsin. Okay. Again, pepsin was first introduced in the stomach, okay, by the chief cells, right? They produce the pepsinogen, which get converted into pepsin. But pepsin has a cousin. Its name is trypsin. They are related in terms of how they break down the protein. And then their fats are going to be broken down by lipase, and nucleic acids are going to be broken down by nucleases. So basically, there is an enzyme that is designed to break down each of the macromolecules that we know about. So this shows you how it actually happens. So let's say there's a starch here, which is like basically a long chain of glucose. The amylase is going to break it down into maltose maybe, and then you will need a maltase to break it down into glucose. Then you will absorb it into the blood. Remember, the digestion happens in the duodenum, but then the absorption, it's going to happen in the ileum and the jejunum, the latter two parts of the small intestine. Same thing with the protein. You might have some peptidase to break it down into amino acids, right? The trypsin, pepsin, and then you absorb it. Here is fat. If there's a big blob of fat, the bile is going to make it into smaller droplets. And then the lipase will break it down. into amino acids. Into fatty acids and glycerol. But fats is a little bit different when it comes to absorption, because you know fat does not mix with water, right? So the fat actually needs to be absorbed through the lymphatic vessels, and it's actually going to go to the liver. And in the liver, it is going to get converted into HDL or LDL before it goes into your bloodstream. Okay? And again, the reason is because fat is not soluble, so you cannot absorb it directly into the bloodstream. So, more questions here. Accessory organs, which one is not? So that's accessory. These are all accessory organs. So it's only the appendix that's not. The function of the bile is to, I'll let you take a look at this for a moment and I'll tell you the answer. Okay, the function of the bile is to physically break down the fat, chop it into smaller pieces, right? So it's easier to be further broken down. Purpose of the sodium bicarbonate is to neutralize the chyme in the duodenum. And many people mistakenly choose B, but the neutralization doesn't happen in the stomach. The neutralization happens in the duodenum. Okay, because the duodenum is the part that doesn't have the mucus, right? All right, finally, last few slides. The large intestine contains the cecum, the colon, and the rectum. Okay, so there is a sphincter right here, the ileocecal sphincter, that prevents the food, the material from moving backwards into the small intestine. The large intestine is primarily for absorbing water, salt, and some vitamins. Okay, by this time, most of the nutrients are absorbed. All the amino acid, glucose, fatty acids is already absorbed in the small intestine. Right now, it's just water, some dissolved vitamins. There are actually bacteria that's living in our large intestine that produces some vitamin, and we're going to be absorbing them. Whatever it's not absorbed is going to get eliminated through the anus. So we need to have fibers in our diet. Not having enough fiber is actually going to reduce bowel movement. And when the peristalsis is slowed down in the large intestine, the food is staying there for too long, and you are over absorbing the water. Right? So it becomes difficult to go to the bathroom, and that is constipation. On the other hand, when a person has food poisoning, the stuff is moving by the large intestine too quickly. You don't have enough time to absorb the water, and that leads to diarrhea. Okay, so you need to have the fine balance. Okay, feces. It's mostly water. Right? There's a bit of solid in it, right? About 25%. And when we break down the bilirubin, learn about that in the red cell stuff, right? The bilirubin is gonna be in the bile, which is gonna be added to the food that we break down, and that's why the brown color of the feces that came from the bilirubin. Also, when we break down red cells, there is a bit of oxidized iron in it. That also tends to turn the color a little bit darker. Like I said, there are various bacteria that lives in our intestinal tract. The normal floras, right? We learned about that in the immune system. And they actually can produce various things for us to absorb. Okay, vitamins and fatty acids and whatnot. And of course, these bacteria can release some unpleasant gases And then these gas sometimes can cause bloating, right? And then it creates a gas that might come out in the other end. And finally, there is two sphincters at the end, at the anus. There's the internal anal sphincters. This one is not under voluntary control. We cannot control that. The external one is the one that we can control. Okay? But the control doesn't actually come until, about 18 months. So, toilet training too early might not yield the desirable outcome because they physically do not have the neuronal connection, to control it. Okay, you need to have the descending pathway, right, with the myelination and everything to have that physical connection before you can control it. So most studies agree that it has to be above 18 months and older before voluntary control is possible. Okay, so that's it. Yeah, I know I rushed through the things a little bit today, but it's not very difficult material. Certainly not. It's pretty straightforward, I would say. Okay, it's not as complicated as the nervous system one. So go through the material yourself and see if you have any questions. Then you can ask me. So this is the new schedule, right? I believe I posted up. What day? Today is the 13th. Okay, so I think the lab quiz is already available. I just have to adjust the due dates. And then next week we just gonna do the renal system now. Okay. Renal is very complicated. Right? It's definitely gonna take like a lot of explanation and 2 classes for it. We don't have time to do a test review, so I will post a test to review for you to go through yourself. With the test to review package, and I'll just post an old video from it as well. Yeah, and the test is gonna be on the 25th. Okay, I don't know if I'm gonna have a class on the 25th yet. I'm hoping we don't have to, so that you can focus on doing the test. But I will have a better idea once we've gone through some lesson on the renal system. Okay, well that's it. Thank you for coming. If you have any question, please email me. Otherwise, have a good rest of your week. Take care, guys. Bye-bye.